Welcome back and Happy New Year in advance. Till long day after, today I am in my channel. Actually, my mother's back L3 had broken in October month. So I cannot publish any video. Oh, till long day after, today I have discussed one video just as a review of linear algebra, which had come in different type of exam in CSir net. Just as a review, because in few months later there are some exam, one CSir net, another GATE exam. So just as a review, today I have defined some example, just basic question. Let's see the question. Question, which had come CSir net 25 July 2024 exam. The question is very important and very interesting. The question is, let A be 10 cross 10 real matrix. Assume that rank of A is 7. Then which of the following statement is necessarily true? Option 1, there exists V belongs to R10 such that AB not equal to 0 but A square V equal to 0. Second option, there exists V belongs to R10 such that A square V not equal to 0. And option 3, A must have non-zero real eigenvalue, and option 4, A to the power 7 equal to 0. Which of the following are true? Very interesting. At first I will tell you, just try to ownself. Here given A is 10 cross 10 matrix. A is 10 cross 10 matrix with rank 7. Here notice first A must have non-zero real eigenvalue. For this, at first consider 10 cross 10 matrix, and we all of us know nilpotent matrix. Here A is 10 cross 10 matrix with rank 7. This, consider this type of matrix. Notice here rank 7. 1, 2, 3, 4, 5, 6, 7. But this matrix is strictly upper triangular matrix. We all of us know strictly upper triangular matrix always be nilpotent. So this is the trick, actual trick. I hope my all viewers have understood. Strictly upper triangular matrix always be nilpotent. Here, since the matrix is strictly upper triangular, so obviously this matrix is nilpotent matrix. And here 10 cross 10 matrix with rank 7. Option 3, we can consider this type of matrix. Here matrix of rank 7 with 10 cross 10 matrix. But notice here for third option given A must have non-zero real eigenvalue. Is it true? Since here this is the nilpotent matrix, so obviously eigenvalue is 0. All eigenvalue is 0. So A must have non-zero real eigenvalue. This is the wrong option for this matrix. By this matrix, we can break this option third. And option 4, A to the power 7 equal to 0. Is it true? For this, if we consider one 7 cross 7 matrix, 10 cross 10 matrix such type, this is I7, this is 0, this is 0, other part is 0. Then obviously, here since this is the I7 matrix, so obviously A to the power 7 would be such type of matrix. So a to the power 7 is not equal to 0. I hope my all viewers have understood. So option 4 also wrong option. And option 1, there exists V belongs to R10 such that AV not equal to 0 and A square V equal to 0. For this, for all is not for all. This is restricted for only one. If we can to find one such type of V such that AV not equal to 0 but A square V also not equal to 0, then first option would be wrong and second option would be right. For this, consider A equal V, consider such type of V equal to 1 0 0 here 7 0 0 10 times, this would be occur 10 times, and here AB, if we consider this A, then obviously here A square equal to A. Then for this V, AV not equal to 0. Also A square V not equal to 0. That means this example we can delete option 1. For this matrix we have got one vector V such that AV not equal to 0 and A square V also not equal to 0. So option 1 also wrong. Only option 2 is a right option. There exists V belongs to R10 such that A square V not equal to 0. This is only right option. I hope my all viewers have understood this type of question. This question actually conceptual, just as a review. This type of question, this type of knowledge I have discussed in my previous video about nilpotency. If you don't see my previous video, at first see my previous video of linear algebra. I have given some link in description box. Next example, this is very important. Let T be R cube to R cube be a linear transformation which satisfying T cube minus 3T square equal to minus 2I, where I be the defined from R cube to R cube is the identity transformation. Notice here T be a linear transformation which satisfying this property. That means this is actually the annihilating polynomial. It may be characteristic polynomial or minimal polynomial, but actually since here not defined, is it characteristic polynomial or is it minimal polynomial? So obviously this is the annihilating polynomial which annihilate this linear transformation. It may be characteristic polynomial or it may be minimal polynomial, because we all of us know annihilating polynomial does not imply always characteristic polynomial or minimal polynomial. It just annihilates with this linear transformation. It is characteristic polynomial, then they indicate this notation T be a linear transformation who is satisfying the characteristic polynomial. But here just only indicate who is satisfying T cube minus 3T square equal to minus 2I. This is actually, we can tell, this is actually annihilating polynomial. Then which of the following statement are true? Option 1, R cube must admit a basis B1 such that the matrix T with respect to basis B1 is symmetric. Option 2, R cube must admit a basis B2 such that the matrix T with respect to the basis B2 is upper triangular. Option 3, R cube must contain a non-zero vector V such that TV equal to V. Option 4, R cube contain two linearly independent vectors V1, V2 such that TV1 equal to V1 and TV2 equal to V2. Which of the following are true? Notice first option indicate R cube must admit a basis B1 such that the matrix T with respect to B1 is symmetric. This is actually the definition of diagonalizable. We all of us know an operator T is said to be diagonalizable if there exists a basis beta of the vector space B such that matrix representation of this operator T with respect to the basis beta is a diagonal matrix. This is the definition of diagonalizable. When matrix representation with respect to the basis is a diagonal matrix, then we can tell this operator is diagonalizable. And when this is the diagonal matrix, we all of us know diagonal matrix always be symmetric, always upper triangular. Notice here indicate R cube must admits a basis B1 such that the matrix T with respect to this basis is symmetric. Second indicate R cube must admit a basis B2 such that the matrix 2 with respect to the basis B2 is upper triangular. At first, notice this annihilating polynomial t cube minus 3t square equal to minus 2i. We can write this as xr cube minus 3x square plus 2y equal to 0. Just split it. X square minus xr cube minus x square minus 2x square plus 2x minus 2x plus 2y equal to 0. From this expression we can write x square times x minus 1 minus 2x times x minus 1 minus 2 times x minus 1. And these imply x minus 1 times x square minus 2x minus 2 equal to 0. That imply we can write, since this is the second degree polynomial, so root can be alpha beta, root would be alpha beta, x minus, consider x minus beta, this would be the root. So also the definition of diagonalizable, we all of us know this is one definition. Another definition of diagonalizable, we all of us know, if the minimal polynomial of the transformation contain the product of linear factor, then this transformation is called diagonalizable. We all of us know when the minimal polynomial is product of linear factor, then we can tell this transformation is always diagonalizable. So from this expression we can tell minimal polynomial, we all of us know minimal polynomial always divide annihilating polynomial. So minimal polynomial can be either x minus 1 or x minus alpha or x minus beta or x minus alpha times x minus beta or x minus 1 times x minus beta or x minus 1 times x minus, here x minus beta, x minus 1 times x minus alpha or x minus 1 x minus alpha x minus beta. This is the possibility of minimal polynomial. So notice here all minimal polynomial be linear factor. So we can tell by these rules, since the minimal polynomial of this transformation contain product of linear factor. So we can tell this transformation always be diagonalizable. That means actual definition of diagonalizable, there exists a basis of this operator such that matrix representation with respect to this basis always diagonal matrix. Since this is the diagonalizable, so notice here R cube must contain admits a basis B1 such that the matrix T with respect to this basis B1 is symmetric. Diagonal matrix always symmetric, we all of us know. So option 1 is a right option. Option 2 indicate R cube must admit a basis B2 such that matrix T with respect to this basis is upper triangular. We all of us know diagonal matrix always be upper triangle. So option 2 also right option. Third option indicate R cube must contain a non-zero vector V such that TV equal to V. Here notice, here indicate R cube must contain and TV equal to V means we all of us know if TV equal to lambda V, then lambda is eigenvalue. Here TV equal to V means lambda equal to 1. That means eigenvalue is 1. We all of us know root of the minimal polynomial is always root of the linear transformation. If we consider this type of minimal polynomial x minus alpha times x minus beta, for this minimal polynomial the characteristic polynomial would be such type x minus alpha whole square times x minus beta. From this minimal polynomial the root is alpha beta. Here 1 not be root of this transformation. But here notice, here indicate R cube must contain. If we consider this minimal polynomial, then 1 would be root. But by this minimal polynomial, we can tell alpha beta only root of this linear transformation. 1 cannot be root. If here not indicate this must line, then we can tell R cube may be contain a non-zero vector V such that TV equal to V when the minimal polynomial is such time. But we cannot tell. This is obviously always R cube must contain a non-zero vector V such that TV equal to V for this annihilating polynomial. This is not true. Similarly, option 4, so option 3 is a wrong option. Option 4, R cube must contain two linearly independent vectors V1 and V2 such that TV1 equal to V1 and TV2 equal to V2. From this and from this also 1 be eigenvalue. Similar to before, similar to 3, we can tell since here also indicate must option. So we cannot tell there exist always two linearly independent eigenvector V1 and V2 such that 1 is an eigenvalue. So option 4 is a wrong option. This is very easy type question, just as a basic, just as a review. And this question had come 2023 June exam in CSir Net. I hope my all viewers have understood this question easily. Okay? Oh well. I will stop here. I hope my all viewers have understood today's question briefly. Okay? See you soon. Stay safe and stay positive always. And don't forget to do subscribe my channel for more videos. Thank you so much.